Hello, my dear students and the rest of the learners. Welcome to part 18 of a 7-part series of tutorials in computer structured programming in C and Pascal. This is section 1 of 4 in the topic subprograms. My name is Meme JM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at the definition of subprograms, and then I'll look at the types of subprograms. Under this, I'm going to look at the procedures, or what we call void functions in C. I'm also going to look at the functions, or what we call non-void functions in C. And lastly, I'm going to look at the inbuilt functions in C and Pascal. Let's commence by looking at the definition of subprograms. Most computer programs that solve real-world problems are much larger than the programs presented so far, or than the programs that I have been able to demonstrate or to use in the last part of the presentations in this series. So, when dealing with large programs, it's always advisable to break them down into simpler parts, with each part performing a specific task. And then these parts can later be linked together into one main program. These parts are referred to as subprograms, modules, or subroutines. A subprogram is therefore a segment of code organized as a single unit that performs a particular task within the main program. So, when writing, especially a large or a long program, you should identify the various tasks to be performed by the program, and then you write a subprogram for each task. In other words, if you have a large program or a long program performing several tasks, break each task to be a separate subprogram so that each module performs a specific task, and then once you have developed all the modules, you can link them together or merge them together to form the main program or the whole program. Generally, the best way to develop and maintain a large program is to construct it from smaller pieces or modules, with each of those modules performing a specific task, and thus managing each module separately from the original program, and then you merge all of them to form the original or the main program. And therefore, each of the modules becomes more manageable than when you are managing the whole or the original program. This technique is called divide and conquer. Subprograms are said to be self-contained or self-sustaining because they include a program header. They are all variable declarations and contain the appropriate sequence of statements as well as formula for doing the appropriate work. In other words, a subprogram is coded just as you would code a main program, because just as the main program contains certain elements, the same elements are contained by a subprogram or in a subprogram. Therefore, each subprogram has what we call a subprogram header and body, just as it is for a program. This means that subprograms have a structure similar to that of a program and can thus be referred to as mini programs. Subprograms are useful in organizing large codes such that there are groups of codes with each doing a specific task. This makes the code easy to write, easy to read, and easy to modify. It also avoids rewriting the code every time it is required within a certain section of the main program. So, to perform a task many times in a program, instead of duplicating the code to do so, it is good to write the code of doing the task in form of a subprogram, and then just call that subprogram every time you need to perform that task. The subprograms are represented by names assigned to them at the point of definition and are invoked or called within the main program whenever the segment has to be executed. And therefore, a subprogram is executed when its name appears in the body of the program. The occurrence of a subprogram's name in a segment of code is referred to as a call. In fact, a subprogram's call is written within the main program just like an ordinary instruction, but to just list its name and any arguments that it requires. So, all subprograms are invoked by a subprogram call, which specifies the subprogram's name and also provides additional information such as arguments that the code subprogram needs to perform its designated task. This information that is passed to the subprograms is called arguments. And therefore, a subprogram call statement within the main program can contain arguments, or it can just be empty without any arguments. The calling subprogram asks the called subprogram to perform a task and report back when the task is done. This calling of subprogram can call more than one subprogram based in the order of their call statements. In other words, the calling subprogram can call more than one subprogram based in the order of their call statements or based on the way they are listed within the calling subprogram. So, the subprograms called by the main program are implemented in a certain hierarchy depending on how they are arranged in the calling function. The first call statement calls the first function. The next call statement calls the next function. And that is the order, that's the hierarchy, from the first called subprogram to the last called subprogram. Peer subprograms are the subprograms defined at the same level in the hierarchy and are at the same level of nesting. They can be invoked from the main program and they can invoke each other. Nested subprograms are subprograms whose declaration has been placed within the declaration of another subprogram. Usually, the subprogram's declaration is placed before the body of the program. The positioning is intuitive. That is, when the subprogram is called from the main program, it should have been declared earlier. A subprogram prototype is therefore a line telling the translator of the existence of a subprogram somewhere later in the program with a particular name, return type, and parameters, including their sequence and types. In other words, if you don't want to write the entire subprogram before you go to the main function, you can just declare what we call, or can just write what we call the subprogram prototypes, and then you can do the definition later after the main function, just as we are going to see in my subsequent presentations. A subprogram prototype tells the translator the type of data to be returned by the subprogram, the number of parameters the subprogram expects to receive, the types of parameters, and the order in which those parameters are expected. So, prototypes are mandatory whenever function definitions have to be defined after the end of the main function. Subprogram calls must match the subprogram prototypes. A subprogram prototype is a subprogram declaration whose work is just to inform the translator of the existence of a certain subprogram, while a subprogram definition is the sequence of statements that inform the translator exactly what is to be done by a subprogram and how it will do it. It's simpler to write subprograms after the main subprogram, especially when writing long programs. And in such a case, therefore, it is important to declare what we call the subprogram prototypes. This is because it is easier to identify which subprograms we need in the program and list them as subprogram calls in the main program. We then define them after the main subprogram. It is important to prototype your subprograms, especially in C, before the main program or before the main function, so that when the compiler is compiling the program from top to bottom, it does not encounter subprogram calls calling subprograms which have not yet been encountered. Any subprograms that will be called by others should be defined before those that will use them. The subprogram's prototype is the same as the first line of the subprogram's definition, but terminated with a semicolon. The names of parameters in the prototype are dummy variables. That is, they are not needed. We just need to show the compiler the number and the type of parameters in the subprogram. The translator uses subprogram prototypes to validate subprogram calls. Let's now look at what we call the types of subprograms. There are two main categories of subprograms, which are: one is the standard or inbuilt subprograms, which are the intrinsic modules that exist within a programming language's translator, predefined or pre-designed to perform certain tasks. Number two are what we call the user-defined subfunctions. These are the modules that are coded by the programmer as part of the program with an intention to perform certain specific tasks. In addition, all the subprograms can be divided into two main types, regardless of whether they are inbuilt or user-defined. These are the procedures and functions in Pascal, or void and non-void functions in C, respectively. So, procedures in Pascal are referred to as void functions in C, while functions in Pascal are called non-void functions in C. Let's look at procedures, or what we call the void functions. These are self-contained subprograms that execute on their own in the main program while accepting many inputs and returning no value. They are mostly used to do some operation that does not need answers to be returned, but instead computes and outputs some value. Some properties of a procedure include: number one, it has a unique name associated with it that is used to call it. Number two, they can receive as many values as possible, but don't return any value back to the caller, and can output as many values as possible. Number three, no value is associated with the procedure name. In Pascal, a procedure is declared as follows. We have the keyword procedure, followed by the name of the procedure and optional parameters. For example, if you have a procedure called inputting, then we declare it as procedure inputting. Then opening parentheses, or what we call the left parenthesis, and then we have our first parameter, name, which is of type string, and then age, which is of type integer, with the closing parenthesis or the right parenthesis, and then semicolon. While in C, a void function is declared or prototyped as follows: void followed by the name of the function, and then the parenthesis followed by optional parameter. You have the closing parenthesis or the right parenthesis and a semicolon. For example, void inputting. First parameter is name, which is string type or an array of characters not exceeding 10. And then we have the other parameter called age of type int. My dear students and the rest of the learners, kindly note that the optional parameters can be written just in the same way we declare them at the declaration sections, either in Pascal or in C. The definition of a void function in C is as follows. So if, for example, you defined or you declared, if you declared a function called void inputting, then we have an array of characters and age as parameters. We can have a function defined. For example, void inputting followed by optional parameters. But in our case, let's use name as our void function. So we can define void function in C as follows: void followed by the name of our function, then optional parameters. And then we have the left parenthesis, not parenthesis, but the left brace. Then we have the statements to be executed, with each statement being terminated with a semicolon. And then we have the right brace to block our statements. So that's how we define. So we declare by having only the handler, as we have seen. For example, void inputting car name 10, then int age. We have the parenthesis and a semicolon. So when we are declaring, we terminate each function declaration with a semicolon, and we only have the header of the function. And when we go to definition, we have that same header, but then we don't have a semicolon, and then it is followed by the block of statements to be executed. Like in this case, we have the left brace, the statements to be executed, and then we block it with the right brace. While the definition or structure of a procedure in Pascal is as follows: we have procedure followed by the name, and then we have the optional parameters enclosed in parentheses followed by a semicolon. That's how we declare. But then when it comes to definition in Pascal, we also define it just in the same way we declare. But note the difference. Under the declaration, we have the procedure followed by the name and the parameters. And these parameters are written in the same manner that we declare them in our declaration section by including the name and the type of parameter, the type of value to be received and stored. But when it comes to the definition, we have the same as the header or the declaration, but then we now include the variable declaration part and begin the body and the end. And therefore, a procedure, as you can see in Pascal, resembles the body of or the structure or the format of the program in Pascal, but instead of having a period on the last part where we have the reserved one end, we put a semicolon. We put a semicolon. And then instead of having the keyword program, we just replace it with the procedure. Instead of the keyword program, we replace it with the procedure followed by the name and optional parameters. We have the variable declarations as usual. We have the begin as usual. We have the body as usual. And then we have the end as usual. But instead of having a period, we have a semicolon. So we call that definition. Procedures or void functions are just called by writing the name of the procedure and the optional parameters, but ending with a semicolon. So if, for example, you have a procedure declared as inputting, like this one, which I've shown you, this procedure here. So this procedure is called inputting, and this is its declaration. So the core statement for this procedure will be inputting followed by the arguments that are supposed to match with the parameters. And therefore, when you go to the call statement, we have our procedure being called by having its name. Our procedure is called inputting, and it has two parameters up there. As you can see, it has two parameters. It has the string parameter and an integer parameter. The string parameter is called name. The integer parameter is age. So in the call statement, we are going to have inputting, and then we have a value to be passed as name and another value to be passed as age. So we are going to have a name or a string of characters being passed as name and an integer or a value being passed and received as age under the parameter. And therefore, let's see. So our call statement has inputting, then we have name and age, terminated with a semicolon. Why is our call statement having two arguments, name and age? It's because our procedure is going to receive two values. One of them will be the name and the other one will be the age. And they must match. If the first parameter was string, then the first argument should match the same, should be string. If the second value or second parameter was integer, then the second argument for that call statement should be integer, as you can see. Let's now look at functions, or what we call non-void functions in C. These are self-contained subprograms that execute on their own in the main program while accepting many inputs, but returning a single value that can be used elsewhere in the program. The main difference between a function and a procedure is that the name of a function has a type associated with it, and it takes a value of the same type, while a procedure name has no type associated with it and does not hold any value. The functions have the following properties. Number one, it has a unique name associated with it, and this name is used to call the function. Secondly, data values can only be sent to the function through the function parameters. Thirdly, there may be several data items sent to a function, but there is only one value that can be returned from it through the name. In other words, a function may have several parameters and several arguments. So a function declaration may have several parameters. The function call statement may have several arguments, but the number of values to be returned by a function is only one. That's why we are saying there may be several data items sent to a function, that is several arguments, but there is only one value that can be returned from it through the name. So the return statement within the function only returns a single value. Number four, the single value returned by a function is represented by the function name. Number five, the function name can be used in expressions. Number six, the function type is the data type of the value returned by the function. In other words, the value that is going to be returned by a function should match with the type under the declaration in the main function. So the value returned by the function should be the same, or the type of the value returned by the function should be the same as the data type declared for the value that is going to hold the returned value of memory location that is going to hold the returned value. A function is declared using a function declaration. This identifies a segment of code and associates it with an identifier. A function identifier is the name of the function used to execute the statement in the body of the function. The function name has a type associated with it. It acts as a placeholder to store a value of the specified type. This value is returned from the function. The function declaration informs the compiler of the name of the function, the type of data returned by it, and the number, as well as the types of actual parameters that must be supplied to it. The following is the syntax of a function declaration in Pascal. So in Pascal, we use the reserved word or the keyword function, followed by the name of the function, and then parameters and the type that will be returned, the type of the value that the function will return. For example, function area. It is going to receive a single value of type integer. So it has a single parameter. And this function is going to return a value of type integer. So n:integer and closed in parentheses, that is parameter. it is the holding place is a location that will hold the value that is going to be received from the calling function. And the value that this function called here will return is integer. While the following is the syntax of a non-void function declaration or prototype in C. We have the return type followed by the name and the parameters. For example, the name of our function is area. It is going to return value of type integer or whole number, and it is going to receive a parameter. It is going to receive a parameter of type integer, and it will be placed in a placeholder called n. So parameters are just placeholders to temporarily hold a value that has been received during the process of execution of instructions within that function or within the procedure. Or it can be int area int, meaning it's only a single parameter that is going to be received. That parameter will be of type integer. So the name of the parameter, the name of the parameter, the name of the memory where that value is going to be accommodated is not an issue. What the compiler is interested with is to know how many values and mostly of what type. So this statement, int area, parenthesis, int n, semicolon, or int area int are the same. The above two prototypes are similar. Functions are defined as follows. That is the structure of a function in Pascal. So after you have declared the function, you can then define it as follows. Function, name, then parameters, return type, semicolon, then followed by variable declaration section. Then we have the begin, we have the body, and we have the end, terminated with a semicolon. So the difference between a function and the way we write a program structure in Pascal is simply that we have the reserved one function instead of program. And at the end, we have a return type, which is not found in the structure of a program, main program in Pascal. And then we end with a semicolon instead of a period. While non-void functions are defined as follows in C, we have the return type, we have the name of the function, and then we have parameters. We have the block of statements enclosed in between the left brace and the right brace. The return type is the data type of the value returned by the function. Name is the function's name, and the parameters are the received parameters, each accompanied by its data type, while the body or statement forms the function's body. The body or statements part in Pascal and C function definitions, respectively, must have, number one, a return statement that assigns a value generated to the function to be sent back to the calling function. This is the value returned by the function. Number two, it should have the processing statements. In addition, local variable declarations are included in the statement section in C function definition. A function is invoked or called by including its name in an expression. The actual parameters are also supplied within parentheses in the same order as in the declaration. My dear students and the rest of the learners, what we call arguments in the call statement can also be called actual parameters. What we call arguments in the call statement is what we call actual parameters. So the calling function contains a statement that invokes the function to be executed. Once this statement is encountered, the local environment for the function is created and the control is transferred to the first statement within the body of the function. When the control returns from the body of its function, it is transferred back to the statement from where the function was called. The value returned by the function is used at the point where the call was made. So the return type of the function must match the context at the point of a call. There are two ways of calling an onboard function. However, the general syntax of this call statement is as follows. So we have variable equals to name, then passed arguments, semicolon. In other words, this statement is go to the function called name and give it or take to it the following values. That is passed arguments, the following values, the following arguments. And then after the function is through with executing the set of statements within it, come back and assign the results or assign the value you have come with. Bring the return value and assign it into the memory location called variable. For example, this statement can be read as follows in Pascal. So this is a call statement calling the function called area, invoking the function called area, in other words, requesting the function called area to perform a certain task. So the function is being invoked or called by having the name area. So this function called area is being called, and it is being called or invoked by also being given a value called n. It's being given a value that is stored in memory location called n. So that function called area, wherever it is going to receive n. It is going to receive a certain value that is currently in memory location called n as its parameter. So it's going to receive that value as its parameter. It will use that parameter to perform certain executions. It will do certain processing. It will execute a certain number of statements, and then it will return a value. That value will be brought back and it will be assigned to the memory location set assigned called result. Or it can be written as follows in C. So this statement, the call statement or invoking statement for a function in C is similar to the one in Pascal. The only difference is the assignment operator. In this case, the name of the function call statement must match with the name of the function in the function header. Also, the number of arguments, their order, and their type must match exactly as they are for the parameters in the called function header. In other words, if in your call statement, you are calling a function and you are giving it one argument or one actual parameter, then where that function is defined, it should have one argument. If that argument, if the actual parameter or if the argument was of type integer, then the receiving function's parameter should be of type integer. In other words, the arguments being passed to a function, must match in terms of their number and in terms of their type and in terms of their arrangement. The first argument goes to the function as the first parameter. The second argument goes as the second parameter. The third argument goes as the third parameter, and their types must match. However, the names of the parameters in the called function header may differ with those in the arguments of the call statement, but they must match in terms of the data type. Also, the value returned by a function should be of the same type as the type of the variable the result returned by a function is assigned to. In other words, the return type by a function, the value being returned, if it is of type integer, it must match with the memory location that is expected to hold or to receive that returned value within the main function. Examples of inbuilt functions in Pascal are: we have numerical functions, which includes ABS in parentheses X. This function returns the absolute value of a variable. For example, ABS negative 40 returns 40. Odd X determines if a specified number is odd or even and returns true if it's odd and false if it's even. For example, odd in parentheses negative 3 returns true. SQR X, it returns the square of an argument supplied. For example, SQR 4 returns 16. SQRT X returns the square root of the supplied argument. For example, SQRT 16 in parentheses returns 4. That is square root of 16. EXP X returns the value of X, where E is a constant and X can be real or integer. For example, EXP negative 1 returns 0.36787944412. To calculate the exponentiation of numbers of type XY, we use the EXP and Ln functions since Pascal has no exponentiation operator. This is computed using the formula EXP in opening parentheses or left parentheses y times Ln. We enclose X in parentheses and we enclose the whole equation or expression, the whole expression with the right parentheses. Then we have Lnx. It's a logarithm function that calculates the natural log of a number greater than 0. For example, Ln in parentheses 1 returns 0. That is logarithm of 1. Then we have round x. It rounds an argument to the nearest integer. Rounding is either up or down for fractions less than 0.5. So it returns or it determines the integer closest to the supplied value. For example, round in bracket 3.32 returns 3, and round 3.5 in parentheses returns 4. Trunc. It truncates or returns the whole number part of a real number. For example, trunc in parentheses 3.57 returns 3. Then we have what we call the string functions in Pascal. One is length, in parentheses x. It returns the length of a string. X is the string itself. For example, name like Meme. For example, length, we put quotes in parentheses, returns 0. Because there is nothing in there. The length is 0. strx is similar to the length function. For example, str happy enclosed in parentheses and in quotes returns 5. That means the length is 5 characters. As you can see, h is 1, a is 2, p is 3, p is 4, y is 5. Concat x. It is used to attach a string to another to form a new string. For example, concat, in the parentheses, we have single strings. We have 3 strings. Then, band, oof. When you concat them, they form one string, which is the band hoof. Then we have copy, in parentheses x, a, b. It is used to extract a substring from within a string, whereby x is the string, a is the position from which extraction should take place, and b is the number of characters to be extracted. For example, if you have a string assigned to name, as that means name is now a string, a variable that has been declared of type string or array of characters, and then inside it, we have stored the constant string as Meme, Julius, Gera. Then if we have copy, and then we enclose in parentheses, name, that is the variable, comma, 8, comma, 9, returns 9 characters from the 8th position from the beginning, which will be, in this case, Ulius me. Ulius me. Then we have other functions which include uses, and the others. So other functions, to be able to use the following functions, you have to include the following statement at the declaration section of your program. For example, uses CRT, that's a function. So some of such functions will include CLR, SCR. It is used to clear the screen at any given point in the program. So in other words, if you have to use other functions, you have to include certain, let me call them files. You have to declare certain items. For example, uses CRT. Those are functions to do with the screen. We have text color, used to alter the color of text characters displayed. For example, text color in bracket white plus blink changes the text to white color and makes it blink. So my dear students and the rest of the learners, if you want to change the color of the text displayed as your output and have it behave in certain ways like blinking, first of all, under the declarations section, declare uses CRT, because it contains various functions. One of those functions is text color. Therefore, within your set of code, within the executable statements, you can include a function like text color in bracket or in parentheses, the color you want, in this case white, and then if you want it to behave in a certain way, like blinking, you put the addition sign, blink. That will make the text to be of white color and blink. Then we have text background function. It changes the text background. For example, text background in parentheses blue. It changes the background to blue color. Examples of inbuilt functions in C. We have what we call the math library functions. These allow you to perform common mathematical calculations. Before you use them, just as I have said concerning uses, here you must include math.h header file in your program because that's where they are defined. In other ones, you should include the preprocessor directive for math.h file. They include sqrx. It returns the square root of a number. For example, sqr in parentheses 16 returns the square root of 16, which is 4. The exp in parentheses xx is always the value, the variable that you want to work on or the function to operate on. For example, this function returns exponentiation of x, e.g., exponent of 1.0. Then we have fabs x. It returns the absolute value of x or absolute value of the variable you assign to it. For example, fabs 10.15. Then we have seal. It rounds the value you have assigned to it as x to the smallest integer, not less than x. For example, seal 9.2 returns 10. So in other ones, it rounds up. It rounds up. Then we have floor. It rounds the value assigned to it, the decimal part of the value assigned to it, to the largest integer, but not greater than x. For example, floor 9.2 will return 9.0. Note, seal 9.2 returns 10. Floor 9.2 returns 9. Then we have POW x, y. In other words, this function receives 2 arguments. It raises the first argument to the power of the second argument. That is x raised to y. So POW parentheses x comma y simply means raise x to power y. For example, POW in parentheses 2,7 returns 128, meaning it is 2 raised to power 7. So you raise 2, or it is 2 raised to power 7. In other ones, it's like multiplying 2 times 2 times 2 times 2 times 2 times 2 times 2 7 times. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. Raising 2, multiplying 2 by itself 7 times. So it is raising 2 to power 7. Then we have what we call character library functions. These are used to perform useful tests and manipulations of character data. Characters are often manipulated as integers because a character is C, or character C is usually 1 byte integer. Before you use them in a program, you have to include the file ctype.h in your program. ctype.h in your program. In other words, if you have to use functions that work on strings or on array of characters or on the characters, then you should include ctype.h as a preprocessor directive. So you should have #include ctype.h in your program. So such functions include is Ln x. It determines if argument x is alphanumeric or the value or that a variable or constant is alphanumeric and returns a non-zero value if it is true and a 0 if false. Is alpha. This function determines if argument x is alphabet. In other words, if what you have given it, the value you have given it, is an alphabet. Is digit. It determines if argument x is a decimal digit. Remember, when I use x in this case, I'm referring to a content of a memory location or just a value. So is lower. It determines if argument x is lowercase. Is upper. It determines if argument x is uppercase. To lower, it converts a letter to lowercase. So if, for example, you assign it a capital C, it will return small c. For example, int to lower, int c. In other words, if you have a function, if you have the function called to lower, receiving an argument or a parameter of type C, it returns a value which is integer, but in lowercase. Then to upper, it converts a letter to uppercase. We also have what we call string functions. These functions convert strings of digits to integers and floating point values. To use them, you must include the general utilities file standard library.h in your program, that is stdlib.h. So in other words, if you have to use the functions for working on strings, and those functions include, for example, converting strings to integers and to floating point or floating point values, then you have to include stdlib.h in your program. In other words, you should have the preprocessor directive for the header file called standard library. So such functions include atof. S represents the string that you are passing to it. So it converts string S to a double precision quantity. Atoy converts a string to an integer. That's the string passed to it to an integer. Atol, it converts the string passed to it to a long integer. strcmp, receiving two parameters or two arguments, it compares two strings, the first string and the second string, to see if they have what we call, if they are similar or if they are different. So it compares two strings, string 1 and strings 2, lexicographically. It compares two strings S1 and S2 lexicographically. Then we have CTR-CMPI. It receives two strings, string 1 and 2. It compares two strings without regard to case. Then we have CTR-CPY, STR-CPY, receiving two strings or two arguments, string 1 and string 2. It copies string 1 or it copies string 2 to string 1. It copies string 2 to string 1. Then we have strlen receiving a single parameter. So this one returns the number of characters in the string passed to it. And with that, my dear students and the rest of the learners, we have come to the end of section 1 in this topic. Continue to section 2 of 4 in this topic so that you can learn more about functions or sub-functions or subprograms, that is procedures and functions, void and non-void functions, including being able to see demonstrations of sample programs implementing what we have seen or what I have explained in this presentation. So congratulations for learning section 104 of the topic subprograms. You can also access section 2 to 4 of this topic, other topics in the computer structured programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and let's meet in part 19 of this series. God bless.